Good morning. We are starting chapter 8, where we are going to look at two sample tests. In 8.1 and 8.2, we concentrate on two sample tests for independent samples. And so at the beginning of 8.1, they talk about the difference between the two. So let's just look at a couple of examples. My first example has us comparing one sample of 65 students before their freshman year, and then the second sample is the same 65 students after their freshman year. I don't even think I need to give you a definition. I think you would say these are dependent, but if you come back and look at the definition, each member of one sample corresponds to the member of the other sample. It fits the definition. The second example, we're looking at scores of 38 males compared to 50 females. Definitely independent. The only way it wouldn't be independent is if somehow the 38 males and the 50 females were related, but it does not say that in this problem. Same thing goes for example 3, another independent. And then example 4, we're looking at midterm scores of 14 students and then final exam scores of the same 14 students. So they're dependent. Again, in 8.1 and 8.2, we're only dealing with independent samples. So here's the three different ways that you could write your hypothesis test. But regardless of which one we use, we always assume that mu1 equals mu2, meaning there is no difference between the population means, that they are the same. To run a z-test, it's the same stuff as before, so nothing new. The only thing that got uglier was how to calculate z, which you can clearly see here. This is your denominator. Gross. T, very similar. This formula did not come out when I copied it over, or what happened. So here's our formula for T. The only thing that's different is that the error, which is this denominator piece, and the degrees of freedom are calculated differently depending on what you know about the variances of the population. So, with that said, let's just try one. So you can scroll through all that miserable mess later. My problem here is a credit card group that's watching says that there is a mean difference in the credit card debts in California and Illinois. They do two random samples and we see the results here in the table. We are going to use z because sigma is known and n is large. And to calculate z, we need to do x bar minus x bar. So that's your x1 bar minus your x2 bar. Then minus mu1 and mu2. Well, that's 0 because we said that they were the same. Over the square root of standard deviation squared over n, and the other standard deviation squared over n. Everyone can punch buttons on their calculators, so we'll look and see what z is. So with a little bit of benching on your calculator, you should get negative 0.82-ish. Now, I jumped ahead a little of myself in the process that I usually do, maybe because I'm tired, but the ho and the ha need to be established before I can go any further. So the mo is that they're the same, and the ha is that they're different. And there's no direction on this one because they did not specify greater than or less than in the prompt. So the claim is that there is a difference. And so we have a two-tailed test. To run a two-tailed test, you should probably stay on the page you're writing on. And you need to do 2 times the probability that z is what compared to that negative number. Well, you always want the tail part of it, so you're going to have to do less than. And you need to look this value up on your table and then double it. So I used my technology to get that value. It is quite large. Then when I double it, it's even larger. What a thought. So what do we do with our p-value? We compare it to our alpha level. The alpha level is 5%. This is clearly larger. My p-value is greater than my alpha level. Therefore, I do what? I fail to reject the null. What does that mean for my problem? The problem wanted me to see if we could support the claim. If I fail to reject my null, then I'm coming in and saying okay to this one and boo to this one. So, can I support their claim? And the answer is no, I cannot. Alright, let's try one more. This one would use a t because sigma is unknown. The sample sizes are small, and we don't even care what this problem is about at this point. I think you guys have quit reading the problem and you're just crunching the numbers. But it's results of state math tests for random samples of students taught by two different teachers in the same school. So I would claim actually that they are dependent in some way, but the variable here is the teacher, so I'll have to let my statistics side of myself slide there. So we're going to assume this is independent. The populations, we were told, are normally distributed and the variances are not equal. So we can come in and use t for this problem. Now, the question says, can you conclude that there is a difference? So can you conclude that there is a difference? So again, I'm running a two-tailed test. So let's set up our null would be that the means of the populations were the same. The alternative is that they're different. And the results are shown below. Can you conclude that there is a difference? There's not really a claim here. They're just asking us to answer a question. So we'll come back and look at that in a second. We're going to use t. And we know to do t, we need to subtract the mu's. Subtract the x bars. Subtracting the mu's is going to result in 0 because we're assuming they're equal to each other. Then the divisor part depends on what they tell us. So right here where it says population variances are not equal, scroll back up. Population variances are not equal right here. We need this formula. So it is the exact same formula for sigma that we saw a minute ago. Degrees of freedom is the smaller of the two. So we're going to come back down here. We're going to put a giant square root sign. S1 squared over n1. S2 squared over n2. And that'll calculate our t. Our degrees of freedom will be 7 because the smallest sample size was 8. 8 minus 1 is 7. Okay, so I'm not going to have time to finish this problem for you before my video cuts off. But let's talk about how you would finish it. You need a p-value that's been doubled. You need the probability that t is greater than that value, and you need to use degrees of freedom of 7. If you use the table, you cannot get an accurate enough answer to answer on my StatLab. So you can go into StatCrunch, go to Stats, go to Calculators, go to the t calculator, and ask it to find t is greater than 0.9224 with degrees of freedom of 7. If you do that, you should roughly get an answer of 1935. And then we still need to double it. So this is quite large. I said I wasn't going to finish the problem, and here I am finishing the problem anyway. That's quite large. We fail to reject the null. If we fail to reject the null, then we say okay to this one and not okay to this one. The question was, can you conclude that there's a difference? The answer is no. So although the sample means were different, statistically speaking, we don't have a difference. Okay, I'm done with you. I will come back and do a couple more examples just for fun. So stay tuned. Laters.